Okay, so to begin this lesson, what we're going to do is look at our formulas for the different components of motion. The first type is our straight line motion, which we're pretty familiar with at this point. Firstly with V equals U plus AT. This one we haven't seen before, which is V squared plus U squared plus 2AR. Remembering that V is final velocity, U is initial velocity, A is acceleration, and R is displacement. We then have R equals UT plus half AT squared, R still being displacement. Moving on to horizontal components. So this is only when we're looking at the horizontal component are we going to use these ones. And most of them should be pretty straightforward, I think. This is one we looked at previously based on trigonometry. Ux, which is the initial horizontal velocity, equals U cos theta. Then we have Vx equals Ux, which we looked at last lesson as well, because we know that the horizontal velocity doesn't change, so obviously the initial horizontal velocity will also equal the final horizontal velocity. This one here, change in x equals uxt, is derived from speed equals distance over time. So if you rearrange that, you obviously get distance equals speed times time, and that's exactly what this is. That distance is the change in x equals the speed times time. Moving on to vertical components of motion, we get this one, which once again we did last lesson from trig. Then we have this one, which you'll see it's the same as V equals U plus AT, except that those little Y's mean that we're only looking at the vertical components. And in this case, in most cases, if you're looking at a projectile question on Earth, that AY will be the acceleration in the vertical direction, which is usually gravity, which will be minus 9.8 unless specified otherwise. Then we have this one, which also comes from our straight line motion, but once again using only the vertical components. And the delta y there is in the other one it was displacement. And once again, same thing, just with the vertical components put in there. Now, when we're using all these different formulas, we're often going to have to use more than one formula to solve a problem. And as such, you need to store your numbers because they often have very large decimal places. And if you round them off early, you're going to get an incorrect answer in the end. So it's really important to know how to store your numbers. It's a pretty straightforward process. Obviously, with a sharp, it's a little bit more straightforward in that we just press the store button and then any one of those buttons in that line, so Y, X, log, all those ones in that line, they can all be stored in there. In a Casio, we're looking at shift recall. Obviously, when you press the shift, the recall becomes store. And once again, all those lines in that all the buttons in that line. Then obviously you need to recall the numbers. In the sharp, once again, it's a straightforward process. You press the recall button and then where you stored it. In the Casio, nice and simple again, recall that button. Deleting the memory in the sharp, you've got the second F plus mode. In the Casio, it looks like it's more complicated, but it's only because the Casio gives you more options. And pressing Shift 9 opens up those options to delete different parts of the memory. And you can just follow through the prompts, but otherwise it's just 2 equals AC. Now, we've already discussed that the horizontal and vertical components of motion are independent. So the only force acting on a projectile is the weight force, which acts only in the vertical component. Therefore, no force acts on the horizontal component, and thus it remains constant. As you can see by these arrows, it's just remaining constant. So the initial horizontal velocity always equals the final horizontal velocity. In the case where the projectile is launched horizontally, as it is in this picture, from a height, the horizontal component makes up the total initial velocity, and therefore the horizontal velocity also equals the initial velocity. For horizontal projectiles from a height, the initial vertical velocity is always 0. This changes pretty quickly though, in reality, the vertical velocity is 0 for only a split second and really barely noticeable, unlike in the Roadrunner cartoon. So to calculate final velocity, vector addition of Vx and Vy will break it into its components. Knowing Vx and Vy using Pythag, you can determine the final velocity. It's basically just using Pythag, but if you want to just quickly, rather than doing a little triangle and figuring it out, you can just chuck in v squared equals vx squared plus vy squared, just to simplify your process there. This formula is given to you. It's just a little neat shorthand. Obviously, then using the trig, you can determine the angle of landing. It's basically the same as breaking initial vertical velocity into its components. So what we want to look at now is a quick example question. It's very much the same as the question in question 1 in your problems for this lesson. But you'll find that other questions will give you different starting information, so you have to use different equations, but you'll get the hang of that. So first, let's look at this example. We've got a tennis ball is hit off a rooftop tennis court at 20 meters per second, horizontally from the roof. The roof is 80 meters tall. Calculate the following. So we're given the initial velocity u of 20 meters per second and the height. The height is the change in y, so delta y equals minus 80. It's minus 80 because it's going downwards. Because it's horizontally launched, we know that the initial velocity will equal the initial horizontal velocity. And because the horizontal velocity never changes, we also know that the final horizontal velocity will be 20 meters per second as well. And because it's horizontally launched, we also know that the initial vertical velocity is 0. So now, in order to find any of the remaining values, we need the total time. So I need an equation that has t as the only unknown variable. I'm going to look at the vertical equations with t, these ones here on the right here. These are the only vertical equations that have t in it. So the first one has Vy in it. We don't have that value, so that one's useless. That leaves us with the delta y equation. Subbing in the known values, including minus 9.8 for gravity, we get this, which we can simplify a bit, and we'll get a value of 4.04 seconds. Now, that has been rounded off there, but I've stored it in my calculator for later use. Now, with that time known, we can calculate the remaining values. Firstly, we're going to look for, I think, delta x using the delta x equation. So we'll sub in the values because we have ux and we have t, and that'll give us a pretty straightforward answer of 80.81 meters, once again being stored in the calculator. Now we'll calculate Vy using V equals U plus AT. When you're writing these equations out in your just in your solutions, you don't have to always write Vy and Uy. If you want to just shorthand it, you can just write V equals U plus AT. Markers will still know what you're doing. Once again, we'll sub in the known values. Obviously, Uy, we know 0, and we'll get a value of minus 39.6. And it's obviously minus, once again, because it is pointing downwards. Now, with both the vertical and horizontal final velocities, we can calculate the final velocity using vector addition. We can determine the magnitude, obviously this way, and then using a bit of trig, we can calculate the angle. So this is, you can see we've used a couple of equations. I think it was 3 or 4, and you'll pretty much need to use a fair few equations for each one. Remember to store all your answers. Make sure you've got it in degrees, not radians, and make sure you're showing your solutions and the equations you're using, because you often do get marks for using equations. So yeah, now go through all those questions. Make sure you complete every single one for this lesson, because it's all about this repetition, especially for projectiles. You need to get them all done. Anyway, get started on those, and then we'll start working on more complex projectiles next lesson.